Hi there, welcome back. This is the second video in this restoration series of the Pi HFS-20 or 20M. And what I've done since the close of the last video is I've checked some of the capacitors that are still in there. They are not in as bad shape as were the two main filter caps, which is a good thing. And fortunately, what I've found is that the resistors are really in bad shape. Those are all carbon comp resistors. They have all drifted very high compared to their rated values. And so it looks like I'm going to have to replace all the resistors, especially in the power amp stage where high voltage was concerned. Now, before I do that, I just want to test something here. And this is actually connected to a very glaring mistake that I made in the last video when I was talking about the so-called feedback circuit going back to the grid of the output tube. Well, obviously, as many of you pointed out correctly, that was not feedback, that's the fixed bias. Now, the first schematic that I saw, the one that turned out to be incorrect, had a cathode bias. I think it had a 150 ohm resistor to ground. So when I went to this schematic, I just didn't check. And this, in fact, does have a fixed bias of 13.6 volts. And that 13.6 volts is established from that 17 volt AC winding of the transformer, the bridge rectifier, and then it goes through a 33k ohm resistor, and it goes to the grids of the EL34s through another 470k resistor. Now, the 33k resistor measures too high, and the actual 13.6, negative 13.6, is actually established on the second part of the circuit. In other words, on the preamp part of the circuit. The voltage comes in fact, the rectified voltage comes in, and it comes in from the power amp, and it says there minus 13.6 at the top, and it actually says plus 4.8 at the bottom. So you've got a total of 17, 18 volts. And the way this 13.6 is established is through the use of two resistors, a 330 ohm and a 220 ohm, which really does act as a potential divider there, with the center connected to ground. So it creates a voltage above and a voltage below ground. The reference is neither of the two main polarities. It's somewhere in between. The first thing I want to do is to make sure that that 13.6, negative 13.6 volts, that is the bias for the EL34s, is correct, because if it is not high enough negative, it will actually cause the conduction to be too high. In other words, the tubes will be too hot, the taps will be too far open, and we could get excess current coming through there, and that again would be another reason why that B plus fuse blew. So I'm going to check these resistors and see what we get. I have to remove these tubes, the two tubes on here, because this point here, pin 5, and this plus 4.8, that's minus, that's plus. The difference between them is 12.6 volts, which is the heater voltage for those tubes. If I leave those tubes in and I try and measure resistances here, it'll be completely cocked up. So I'm going to remove the plug, and I'm going to remove those two tubes, and we can measure what those resistors give us. And they should be, well, we should be able to read them. Let's have a look. So here's the first one. The reference point is ground. This one there is supposed to be 330. That's 348. Not too bad. And that one there supposed to be 220, and it's 316. So that one is completely gone. Just while we're at it, the resistor between those two, which is supposed to be, what is it supposed to be? 33 ohms, is reading 5 ohms, for the simple reason that there's a lamp in parallel with it, which is fine, so that's okay. So I'm going to switch this on and see what bias voltage we're actually getting at the bias voltage we're actually getting at the EL34s. Let's try that. Alright, 2 resistors swapped over. Let's see what we get now. I've put the restriction back to maximum limit. And we don't have fireworks, so I will give it more juice. And what exactly do we get over here? Minus 11.2, minus 12. Still not minus 13. Let's try and bypass this thing. No, minus 12. Still not absolutely there at minus 13 point something volts. But it is better. And what are we getting across here? Let's see. 11.5. Yeah, we got 17.6 volts coming in and 11.5. What I think we're getting is actually a slightly high drop across that selenium rectifier. We should probably have a few more volts over here so that we can get a bigger bias voltage and actually reach the 12.6 volts that's necessary for the heaters. So let me just stop for a second and think as to whether I should just swap out that selenium rectifier. Well, quite a lot has happened since the last clip. As you may notice if you look at the board. When I left off, I said I was considering swapping out that selenium rectifier. And I did actually swap it out. I connected temporarily a bridge rectifier in there and found that it made absolutely no difference. So I put this one back as it is. Then I went and looked for the second time at the capacitors and found that my readings, or my initial conclusion that they were in pretty good shape, was completely wrong. I mean really, really wrong. This 1 microfarad capacitor, which is in the bias circuit, was reading something like 3 or 4 microfarads, and it was leaking like crazy. So what I did was, because it sticks out the top and I wanted to keep it as original looking as possible, I stuffed it in the original aluminium can. So there's a 1 microfarad capacitor in there, brand new Nichicon. It's a 35 volt cap, so it should last a very long time. And then I went and started changing resistors, because these resistors were in pretty bad shape. And I was actually worried as to what those wrong resistor values could be doing to the rest of the circuit when I tested this with those short power-ups, especially with the tubes out, because the voltages do get higher. And because they were all really, really way out, with the exception of the 2 really big resistors, there's a 22 meg over here and a 47 meg over there, I just swapped them all out on both sides. So that was another job done. Then I went and tested voltages and found that I was getting closer and closer to the 13.6 volts, but not quite there. So I went and tested voltages, and the voltages I checked were the voltages on the B pluses, the B2 pluses as it were, after that second filter cap, and I found that this side was not bad at all, but this side was really low. The voltage there is supposed to be about 180, and I think I had about 176 on this side, and I had about 90 on this side. So when I measured the anode voltages over here, they were way, way, way lower, and on this tube they were actually quite close, not bad. So I went and checked these capacitors over here, and as you can probably tell, I found something seriously wrong with them, because I've removed this one. This cap was reading really badly. One half of it was fine, and the other half had something like 15 ohm ESR, which is definitely not a good thing. So I'm now in the process of getting ready to restuff it or to repair it. What I'm thinking of putting in here are 2 22 microfarad Nichicons at 450 volts. I really can't find 16 microfarads at 275. And anyway, I think 275 is a bit low, so I'm going to go for 450 volts. It's always safer. And then I'll be ready to do another voltage test with the power tubes in. So we'll be able to check the actual supply voltages themselves, see if they're correct, and also check the bias on the output tubes, see if we've got that to a reasonable amount. I also found that these caps, these are the film caps, were completely leaky. I took one out and tested it. The values were completely wrong and the leakage was huge. As you can see from this measurement I did there, these are 0.1 microfarad, 350 volts, and the leakage is crazy. So I removed both of them, that one as well as that one over there on the underside. And because I wanted to keep the original look again, I decided to actually restuff it. And it wasn't really difficult. It actually turned out very well. The result looks like this thing is brand new. So we've got brand new caps in there. I chose some good quality caps, and that shouldn't be a problem. Now, one of the reasons I was really concerned about those two is because they actually couple the driving stage to the output stage, and that could have an effect on the DC bias of the EL34. So I wanted to make sure that that was in perfect condition. The other note that I need to make is there's actually a resistor inside the tube socket. What they do is they use pin 6 of the socket, which is not connected internally, and they connect the resistor, which is on the schematic, to pin 6, and then from there the resistor connects to pin 5, which is the actual grid. So you have to make sure you don't forget to replace that one, and those were extremely high as well. And that'll be quite a bit of progress. Now, this is quite a bummer because a hell of a lot more was needed than I thought. And I'm worried, seriously worried, that I won't be able to restuff that middle one there and the one that I've replaced or removed from here, because the caps that I have are a little bit bigger than those. They won't fit, the two of them won't fit into the one can, and I really don't want to risk putting caps in there that are too close to the voltage rating. I can get 250 volt caps, but it's just running it a bit too close to the edge, and I think I'd prefer to find a way to fit them nicely under there and just make sure the quality is in place and the function works very well. So that's the next step. Let me get on with it. And here we have them. I've decided the only way to do them is to put them really back to back and wire them up. The two negatives are wired together at the bottom. Comes out the bottom, and then the two positives come out the top. As you can see, this is all properly wrapped with heat shrink. It's pretty solid. I've just written the values on the side here so we have a reference, and now these will obviously this will fit in here quite nicely. And because it's black and it's not the orange, but it'll look like it fits there. And so I can get these two done and proceed with measuring voltages, see that we've solved that problem. We should have. So now with those caps replaced, and let me show you what it looks like. They actually fit in pretty well. I had to desolder some of the connections to the output transformers so they could fit in there, and then put them back. They've been tightened down again. The one on the left there's got the 22K resistor in place. So everything's back in there, and we're going to power it up with quite a bit of restriction. I've actually got the tubes in there because I've already tested this, and I'm measuring that supposed 13.6, and watch when I give it more juice, we're nearly there. Taking away the limit, 13.24, so that's close enough. Okay. Now the other measurement here is the B2 plus, which is here. It's coming in at 237, and that's on the one side, and on the other side I've got 235, the same voltage. What I do notice is that on the other side of that 56k resistor, on this side I've got 185, and on this side I've got 156. Now, the reason for that seems, well, it does make sense to me, because the supply for the preamp, which goes to both sides of the preamp, actually only gets taken from one side of the power amp supply. So if you look at the other side, this one here, 155, that one there, 184, it means that quite a bit of current is being drawn through that 56k resistor, which is actually going to feed the preamp, which also means that the preamp is probably drawing too much current, which means there's some capacitors in there that need changing as well. So I'm actually quite happy with this so far. It does say there's some voltages there you could test without the preamp connected, but what you might notice if you look carefully at the schematic is that the actual ground reference for this 13.6 volt bias supply actually comes from a grounding that's in that preamp socket connector, the umbilical cord. So if you take that off, you could be in for a bit of a surprise. But I'm happy that's there. The voltages are there. The capacitors have been replaced, and I think that this may well be the complete restoration of the power amp stage. And bear in mind, this hasn't even been tested yet because I still have to sort out the preamp. But I think I'll stop for now, and I'll get back to you as soon as I've had a look at that stage. And I want to thank you for watching, and apologize for some of the lost footage. It seems to have happened again. I do tend to do that quite a bit. But I hope you've enjoyed it anyway, and if you have, please subscribe, share, like, and if you want to support the channel, you can do so on Patreon. Thanks for watching. Bye for now.